A challenge in materials design is that in both natural and human-made materials, volume sometimes decreases, or increases, with increasing temperature. However, a team of Penn State researchers has come up with a theory to explain and then predict it: zentropy. Think of a playroom in a preschool. If no energy is put into keeping it tidy, it quickly becomes disordered with toys all over the floor, a state of high entropy. If energy is put in via cleaning up and organizing the room once the children leave, then the room returns to a state of order and low entropy. Zentropy theory notes that the thermodynamic relationship of thermal expansion, when the volume increases due to higher temperature, is equal to the negative derivative of entropy with respect to pressure, i.e., the entropy of most material systems decreases with an increase in pressure. Every state of matter has its own entropy, and different parts of a system have their own entropy. When we talk about the configuration entropy, different ways particles rearrange within a system, that entropy is only part of the entropy of the system, said Zhi-Kui Liu, Dorothy Pate Enright Professor of Materials Science and Engineering and primary investigator in the study. This is because responses of a system to external stimuli are driven by entropy. Macroscopic functionalities of materials stem from assemblies of microscopic states, microstates, at all scales at and below the scale of the macroscopic state of investigation. These functionalities are challenging to predict because only one or a few microstates can be considered in a typical computational approach such as the predictive, from the beginning calculations, which help determine the fundamental properties of materials. This challenge becomes acute in materials with multiple phase transitions, which are processes that convert matter from one state to another, such as vaporization of a liquid, Liu said. You have these different scales and you can stack them up with zentropy theory, Liu said. For example, atoms as a vibrational property, that's low scale, then you have electronic interaction, that even lower scale. So now how do you stack them together to cover the entire system? So that is what the zentropy equation is about, stacking them together. It creates a partition function that is the sum of all the entropy scales. This approach has been something Liu's lab has worked on for more than 10 years and 5 different published studies. The idea actually became very simple after we studied it and understood it, Liu said. Zentropy has potential to change the way materials are designed, especially those that are part of systems that are exposed to higher temperatures. These temperatures, given thermal expansion, could cause issues if the materials expand. This has the potential to enable the fundamental understanding and design of materials with emergent properties, such as new superconductors and new ferroelectric materials that could potentially lead to new classes of electronics, Liu said. Also, other applications such as designing better structural materials that withstand higher temperatures are also possible. While there are benefits for society in general, researchers could apply zentropy to multiple fields. Along with Liu, other authors of the study include Yi Wang, research professor in materials science and engineering, and Shun-Li Zhang, research professor in materials science and engineering. The work was supported by the National Science Foundation, the Department of Energy and the Department of Defense. Materials provided by Penn State. Original written by Jamie C. Oberdick. Note: content may be edited for style and length. Zikui Liu, Yi Wang, Shun Li Shang. Zentropy Theory for Positive and Negative Thermal Expansion. Journal of Phase Equilibria and Diffusion. 2022. doi. 10. 1007 per second 11669, 022, 00942 Z Penn State. Novel theory of entropy may solve materials design issues. Science Daily. Science Daily. 16 March 2022. ift.tt/hrcndb6. Penn State. 2022, March 16. Novel theory of entropy may solve materials design issues. Science Daily. Retrieved March 16, 2022 from ift.tt/hrcndb6 Penn State. Novel theory of entropy may solve materials design issues. Science Daily. https://ift.tt hrcndb6. Accessed March 16, 2022. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.